In this video, we're going to see how to calculate volume by using triple integrals. So let's imagine that we're in three-dimensional space. And suppose we have a solid three-dimensional region here. Let's call that T. If we wanted to calculate the volume of T, we would say volume is the triple integral over the solid T of dV. And dV here could represent dz, dy, dx. But in fact, there are 6 choices for the ordering of the 3 different differentials. So for example, you could have dx, dz, dy, etc. Let's set up a triple integral for the volume under the plane z equals 6 minus 2x minus 3y in the first octant. So I'd start here just by making a sketch of our plane. So let's think about our intercepts. If we let, say, y and z equal 0 here, that forces x to equal 3. So our x-intercept is 3. If we do a similar thing for y and z, we get a y-intercept of 2 and a z-intercept of 6. Okay, so that's a fast way of finding 3 points on the plane, and then we can just represent that plane as a triangle to see how that plane is tilting through space. So what we're trying to do is find the volume that's lying under this plane and in the first octant, so in the region where x, y, and z are all positive. So there's a visual on that volume there. All right, so to set up our triple integral, first thing we're going to do is slice in the z direction. So I'm going to draw a slice in blue here that just goes vertically like that. It's got its base, or the bottom of the slice is on the xy plane, and the top of the slice is hitting our plane, equation of our plane here, z equal 6 minus 2x minus 3y. So if we ask ourselves what are the top and bottom z values on that slice, let's think about what z is ranging between. Well, at the bottom, z is hitting the xy plane. The xy plane has equation z equals 0. So z's going from 0 at the bottom to 6 minus 2x minus 3y at the top. So these numbers are going to be the limits of integration for our z variable. And then we need to think about what's happening in the xy plane. So we are going to project our solid on the xy plane. So imagine sitting way up here at a very high z value, like z equal 20 or 30, and looking down on your solid. Think about what kind of shadow would be cast on the xy plane by all the points in the solid. Okay, let's see if we can visualize that in the xy plane. So I think it would be helpful here to look at this triangle that's forming the base of our solid. See, it's got a y-intercept of 2 and an x-intercept of 3. And that triangle is actually going to be our projection on the xy plane. So let's see if we can redraw that in the xy plane. Y-intercept of 2, x-intercept of 3, and we're getting that triangle there. Okay, so now we want to figure out our limits of integration on x and y using either vertical or horizontal slices. So we're trying to describe this triangle here, which is our projection, using our choice of vertical or horizontal slices. I would say vertical would work just fine here, so let's go that route. So imagine taking some vertical slices through that triangle there. In order to describe our y values, we're going to need the equation of that line. So let's go to y equal mx plus b. Our y-intercept is 2, and our slope is going to be minus 2/3. So we've got 2 minus 2/3 x for the equation of that line. And then doing our vertical slices in the usual way, we can say y is going to range from 0 to 2 minus 2/3 x. And then as we scan across this triangle here, from left to right, x values are ranging from 0 to 3. So we're pretty much ready to write down our triple integral now. I'm just going to recap the 2 phases of what we did here to figure out our variables. So we first decided to slice in the z direction, and that gave us the limits of integration for z. And then the second phase was to project our solid onto the xy plane so that we can figure out what x and y values to integrate over, and then you can do either horizontal or vertical slices from there. So here we go. We're going to write down our first triple integral. So volume going to be the triple integral of, well, let's think about what order we did our variables in. We did z, then y, then x. So we want our differentials in that order, dz, dy, dx. We said z was going from 0 to 6 minus 2x minus 3y. I'm going to space out the integrals just a little bit more to make them a little bit easier to read. Okay, so for y is going from 0 to 2 minus 2/3 x. And then finally, x is going from 0 to 3. Thanks for watching.